We can also construct a confidence interval for a population proportion. To do that, we've got three possibilities. The first possibility is when we know the standard deviation of the sampling distribution. In this case, we just take the sample proportion, subtract the product of the critical z-score and sampling and standard deviation of the sampling distribution. This will be the lower boundary, and the upper boundary will be exactly the same, just with the plus sign. When we know the true population proportion, what we can do is we take sample proportion and we subtract the product of the critical z-score and the square root out of the population proportion and q, which we know from the previous lecture is estimated as 1 minus p, and divide by sample size. And the upper boundary is calculated in a similar way, it's just instead we put a plus. As we already know, we almost never know the true population proportion. Therefore, the more realistic case is here when we do not know standard deviation of the sampling distribution and when we do not know the true population proportion. To construct the interval, for this case, we take sample proportion and we subtract the product of the critical z-score and the square root out of sample proportion multiplied by q and divided by sample size. The upper boundary is constructed in a similar way, it's just instead of minus we put a plus. There are conditions required for a valid large sample confidence interval for population proportion, as in case of large sample and small sample case for population mean. A random sample must be selected from the target population, and the second condition is the sample size must be large. We already know that for the sample size to be large, the following two conditions must be met. So n multiplied by sample proportion must be higher or equal than 15, and n multiplied by q, which is estimated as 1 minus p, must be higher or equal to 15. Let's have a look at the example how a confidence interval can be constructed for a population proportion. So suppose that a polling agency randomly samples 484 consumers from Florida to find their satisfaction with the state of the economy. They find that only 157 are optimistic about the state of the economy. Use a 90% confidence interval to estimate the proportion of all consumers in Florida who are optimistic about the state of the economy. So we can get the following information out of this description. First of all, the sample size is 484 consumers, and we also know that 157 out of these 484 are optimistic about the state of the economy. So we can calculate the proportion of those who are optimistic by dividing 157 by 484. So we get that the sample proportion, so the proportion of those who are optimistic, is 0.324. Given the value of p, we can calculate the value of q, which will be just 1 minus p, so we get the value of 0.676. We are also asked to use a 90% confidence interval, so we can get the significance level. 100 minus 90 is 10%, or 0.1, and we need the critical z-score. So for alpha divided by 2, which will be the critical z-value for 5%, or 0.05, which we know from the table is 1.645. And here we use the formula. So the third case, when we do not know the standard deviation of the sampling distribution or true population proportion, we substitute everything into the formula. So p with the hat, this is the proportion of optimistic people, 0.324. The critical z-score is 1.645. So p is, we know, is 0.324, q is 0.676, and the sample size is 484. So in the end, we get the value of 0.289 and 0.359. And the conclusion could be the following. We can be 90% confident that the proportion of all Florida consumers who are confident about the economy is between 0.289 and 0.359. So the true population proportion with 90% confidence lies between these two values.